to the east, to the east. Earth rotates or spins. Every 24 hours, another day and night begins. In revolution, Earth circles the sun. 365 days or a year of one. Earth's revolution, funny little tilt. It's the reason for the seasons, the way the Earth was built. When the Earth is tilted away from the sun, its winter cold weather has come. When Earth is tilted toward the sun, it's summer and time for pool fun.
The mass of an object stays the same, weight depends on gravity, and it can change. Matter has 3 states. Solids vibrate, liquids slide, gases move fast. Isn't that great?
High tide, oceans up, twice a day, twice a day. Low tide, oceans low, twice a day, twice a day. High tide, oceans up, twice a day, twice a day. Low tide, ocean low, twice a day, twice a day.
Science fans, today we're going to be looking at the effect of ocean on land. So today we've set up a model and it shows that the water is going to be our ocean, the sand is representing our shoreline and the beaches, and then these pieces of wood is going to be representing homes or beach homes that are on the coastline at the beach. So when I first make my waves with my wave stick, these are going to be your average waves that you see during the day at a beach. So you see that the waves are taking the sand, they are eroding the beach, and it's taking it back into the ocean and depositing it in other places. Now we're going to show you what it looks like if a hurricane or a tsunami came and the waves would be larger, affecting the beaches even more. So these are our big waves. They're reaching all the way up to where the homes and the different establishments are. And as you can tell, the erosion is much more damaging, and you can see the more sand deposited at the lower end of our demonstration.
Go.
Reflection is the bouncing, refraction is the bend, absorption is the stopping. Don't let it in.
Hey science fans, today we're going to learn about, stop.
Yeah, the whole thing. Okay, there you go. Now start.
Alright, hey science fans, today we're going to review the 3 ways that light can be affected when it hits different types of matter. So, normally light travels in a straight line, but once it goes through a certain type of plastic or a certain type of object, the light can be bent or refracted when it passes through the object. So that's one way that light can be changed. Alright, next, light can be reflected. Light is coming out of the box and hitting the mirror and being reflected onto the styrofoam box. So both of these are being reflected. Next, if I take the clear colors out and replace them with solid, or the ones that you can't see through as easily, you can see that the light is no longer being able to pass through as easy. So these are being absorbed, or absorption. So the colors are not easily seen like before.
Light travels in rays from the sun far away. Reflection bounces back. Refraction bends. Blocked light makes a shadow. Makes a shadow. Makes a shadow.
Hey! Today we're going to talk about static electricity. I've got this acrylic rod right here that I'm going to build up static electricity charges on it by rubbing this cloth on it. What I'm doing is I'm transferring electrons from the cloth to the rod in order to build up the static electricity. And we're going to see evidence of that by using these beads right here. And when I pass the rod underneath it, you can see that the beads move. It's following along. because it's following the rod, then we know that the rod and the beads have opposite charges, because opposites attract.
Hey science fans, we're here to check out some different types of circuits. Alright, so what we have right here is we have a series circuit. There is only one path for the electricity to flow. So in a series circuit, I take my energy source, my battery, and I hook it up. And what you're going to see is these light bulbs are very, very, very dim, so they're not lit up very much at all. Now that's the problem with a series circuit, is that since you only have one path for the electricity to flow, it's not going to light up your light bulbs very much. Also, remember that in a series circuit, that if anywhere along the path or the circuit the electricity gets stopped, it's going to cause the other light bulb to go out. So, that's a series circuit, one path for the electricity to travel. So let's come over here and let's check out a parallel circuit. Now in a parallel circuit, you have more than one path for the electricity to flow. This also allows for the lights to be lit up a lot more. So you can tell on these right here, these bulbs are shining very brightly, whereas on the series circuit, not so much. Plus, the other thing about a parallel circuit is that if anywhere along the path the electricity gets blocked, the other light bulbs continue to stay lit up. So this is more like what we would have in our houses. This will allow us to be able to turn lights off in one room and have lights stay on in another. So, this is a parallel circuit. Your two types of circuits. Conductors allow electricity to flow. Insulators won't. Electricity go.
Hey there, science fans. What I've got here is a tuning fork. A tuning fork works because these little prongs right here, when you strike them, they start vibrating. Now we know that sound travels in waves, and we're going to demonstrate that with this tuning fork and this cup of water I have right here. So first, I'm going to strike the tuning fork. I'm going to touch it into the water, and see those vibrations? You see it rippling, and then it's still. Watch again. Keep the water nice and still. There you go. And that's how sound waves travel. Conduction, convection, radiation.
Hey science fans, what we're going to talk about now is we're going to talk about converting one type of energy into another type of energy. So what we have right here is we have some chattering teeth. Alright, so these chattering teeth, right now, I crank it up and I've got mechanical energy, but no sound energy yet. So what I'm going to do is I'm going to take that mechanical energy and I'm going to convert it into sound energy because the teeth are chattering. Alright, the second type of energy that we might going to convert here is we're going to take this mechanical energy right here and we're going to convert it into sound energy. So, I pulled the toy car back, mechanical energy, got it ready. Alright science fans, your trials don't always work like they're supposed to. So let's try that again. Let's try and take this mechanical energy right here and convert it to sound energy. There you go. Whenever it hit the battery, all of a sudden that mechanical energy hits it, you hear a thud, that's your sound energy. The conversion of energy from one type of energy to another.
Hey there. I've got two seemingly identical rubber balls. Now, I say seemingly because they're made of different things. And then we talked about potential and kinetic energy before. Potential energy is energy that an object has based on its position, what it's made out of, etc. It's resting, what it could do. So if this ball is sitting there, it's got potential energy. If this ball is sitting there, it's got potential energy. Now, because they're made out of different things, they do not have the same potential energy. When I change it to the kinetic energy by raising it up and dropping it, you can see this one bounced back up. If you notice, it's not bouncing all the way back up either. So if I'm starting it right here, I'll leave my hand where it is. You see how it drops some. That's because not all the kinetic energy is being returned. Its potential energy starts, drops down to kinetic, and right here it changes. Some of the kinetic gets put back to potential. It only goes up part of the way. Now, let's take a look at this ball instead. Relatively the same height. If I drop it, it just stopped. Now it's got all of its potential energy. While it's falling, it's got kinetic energy. But when it meets the bottom, it's potential. Potential energy stays in place. Kinetic energy wins the race. Friction. Gravity. Magnetism.
Renewable, you replace it. Non-renewable, you dig it.